All right. This is worksheet 8, section 10.3. We already talked last week about geometric sequences. What was the definition?
It's the common ratio.
Yes, they're multiplying by something, right?
Yeah.
To get one term to the next. So successive terms have what's called a common ratio, or R. So you're multiplying by something. So it could be, hang on, my tablet here. It could be you're multiplying by a half. It could be you're multiplying by a positive number. I don't know what's after that. It could be you're multiplying by a negative number. Let's see, let's do 8, negative 16, positive 32, negative 64. So you're multiplying by a negative 2. Does anybody remember what the general form looked like?
A sub 1 multiplied by r to the power of n minus 1.
Yes. Is this explicit or recursive? It is explicit because n is the term number. Okay, you're just putting in the term number. This form will also be on the quiz. Sorry, I didn't write that very well. That formula will be at the bottom of the page on the quiz. Okay, don't have to have that one memorized. Can anybody tell me if it was in geometric sequence what the recursive form would look like?
A sub n equals a sub n minus 1 multiplied by r.
Nice.
And then a sub 1 is whatever term you started from term 1.
You would give me the value of term 1 is 9. And after that, to find the next term, you take the previous term times whatever the r is. Okay, good job. All right. You have this on your sheet then. This is just the notes. Oh, geometric means we need to talk about. When you have a sequence and I tell you there's 3 geometric means between 2 terms, it means they're multiplying by, there's 3 extra terms in between where they multiplied by something. For example, if I went, I think that works. So you would say they multiply by r 1, 2, 3, 4 times. So 1 times r to the 4th gave them 625. Does that seem familiar? R to the 4th equals 625. Now, how do you undo that? You can do 4th root, which is under the math, or do you remember what the other way to do that is?
Power of 1/4.
Power of 1/4. Yep, you could type 625 to the 1/4 power, and that would take the 4th root as well. Okay, think that one's 5, so it was multiplying by 5s. We're going to go on and do a couple examples here. All right, example 1. Find the 7th term of this sequence. What can you tell me?
First term is 8, our difference is -3.
Okay, be careful. This is geometric, so we don't call it a difference. We call it a ratio. Yep. Whoops, then that's not what I wrote. You're multiplying by -3. Remember, to find that, you can take any term, divide it by the previous term, and you'll get the ratio. Now, so how do we find the 7th term?
You know, a sub 7 is equal to 8 multiplied by -3 to the power of 6, or 7%.
Yes, okay. I'm going to write that so we remember where that came from. Should this be positive or negative? A -3 to the 6th power should become positive, right? Because it's an even exponent. If we forget the parentheses, we're not going to get the same answer. So be careful. All right, everybody type that one in. If you don't have a calculator, please get one, because the sum formula is really tricky today. And I want to make sure everybody's typing it correctly, or you're going to struggle later. I got 5832 for this one.
Yep.
Anybody not getting that? All right. Again, here's an example of a geometric mean. It says to get from this term, if there's two geometric means, you multiplied 3 times. So then they ended up cube rooting, etc. Let's try one here. Write a sequence that has 2 geometric means between 6 and 162. So they multiplied by r once, by r again, and by r again. So 6r to the third equals 162. What are we going to do first? We'll get 27. Anybody know that offhand? What's the cubed root? The cubed root is 3. Remember, these kind of questions should be self-checking in terms of 6 times 3, we get 18. 18 times 3 is 54. If 54 times 3 is not 162, then we did something wrong. Everybody good? I went kind of fast, but right. This is weird because this sequence, while it is geometric, is got variables in it. Okay? Term 1, term 2, term 3. You're multiplying by 2, right? So you had an x plus 1 times 2x plus 1, which became 2x plus 2. And then you took 2 of that term, and it became 4x plus 4. So what are the next 3 terms? Anybody? Good job. Everybody okay? What is the common ratio then? The ratio is just 2. Now, just because it's excellent review, if I took this term and if I divided it by the previous term, I should get the ratio. How do you divide that?
Factor out of 2.
Oh, nobody said kill a kitten, right? You have to factor out, and then you reduce 4 over 2 to 2. All right. There was a question on the ACT yesterday where you had to factor before you. Good job, Igor. All right. How do we find the 7th term of this sequence?
First, you got to find the common ratio.
Okay.
Which is -10.
So the common ratio, we could do any term divided by the previous term. So you get -0.3 as the ratio.
Yeah.
Negative though, right?
Yeah.
Okay. So to find the 7th term, we need the first term times the ratio 7 minus 1 times. So 157 times -0.3 to the 6th. Positive or negative?
Positive. Point.
Now, this comes up on the quiz. Is this an exact answer? Yes, because otherwise it would be like 15 places on your calculator, right? And
Yeah.
and if you do a math enter, this actually does change. No, I didn't get mine to change. Did anybody get theirs to change? Yes.
Okay, one of the questions on the ACT, either I did it like completely wrong or I was just like really confused on what to put because it was like.
All right, then we have an example where they give us the 6th term and they want us to work back to the first term. If I write this down, what do we know?
We have our term. So we have A sub n would be A sub 6.
A sub 6. When you, as soon as you talk about A sub 6, what does that mean n is, guys?
N is going to be 5 point.
6,
Yeah,
so
6
6 minus 1 will make it to the 5th,
Oh.
yes. Just so we're clear on that. So 0.1 equals sum A sub 1 times R, which is 0.2 to the 5th. So to find A sub 1, we're just going to take 0.1 and divide it by 0.2 to the 5th. Now, some of you are going to be freaked out by the answer here. What'd you get? Does that make any sense at all?
According to the equation, yes.
Here,
we could work
yeah, we could, but if you're multiplying by 0.2 over and over and over, is this getting bigger or smaller? It's getting smaller and smaller and smaller. So if we want to go backwards to the first term, it had to get bigger, right?
Yeah.
Just trying to help that make a little bit of sense. Okay. Find R if we know the first term is this and the 10th term is this. We could do exactly what we just did, right? The 10th term is the first term times the ratio 10 minus 1 times. So 7680 equals 15. R to the what? How many times did they multiply to get the 10th term? 9. Yep, 9. So you can do the 9th root on your calculator. What do you have to do first, by the way? Divide by the 15. Or you can do to the 1/9 power. First, if I divide by 15, I get 512. And I can show you real quick. Okay, looks like I did it last period already, but if you want the 9th root, you go 9, math, arrow down to number 5 here, and then you put in 512. I'm lazy. I just always do to the 1/9 power because I don't want to find that weird key and remember what order I'm supposed to put it in. Everybody get 2?
Yeah.
All right, is that the answer?
Yeah.
Yeah, that's all they asked for on that one was the ratio. All right, number 5 has a really important typo. Write a geometric sequence that has 3 geometric means between 7 and 568. If it said arithmetic, we'd be really confused. Okay, so that should be geometric means. And I copied that right out of the book's worksheet, so I wish I'd caught that. But so it says there's a 7 and then there's 3 missing terms. And the important thing is that it's geometric, so we're doing what? We're not adding differences, we're multiplying. Very good, Getty. 1, 2, 3, 4 times. You guys solve that one? Anybody else getting 3? Yeah. Okay. So what are the missing terms? Because we're supposed to write the sequence.
21, 63,
7 times 3 is 21. 21 times 3 is 63. 63 times 3 is... And 189 times 3? Did it work? 567?
Yeah.
That's always the check on those. All right. Now, that's really all review. We did that on worksheet a couple weeks ago now almost, I think, because of all this testing. The new stuff is the series issue where you have a list of numbers and you want to find a sum. So if my sequence was 1, 2, 4, 8, 16, the series, the finite series of those 5 terms would look like this. Okay. infinite series would look like this. Now, you can only find the sum of an infinite series if it is convergent. This one is not, right? It's just getting bigger and bigger and bigger, so we couldn't find the sum. This we could. We could find the sum of these terms, obviously. This is this formula that will be on the quiz. I will not give you this one because you can use this one with one extra step. All right, so on your worksheet, this is the one I'm going to give you. Okay, notice it says type carefully. Couple issues. Because the ratio can be negative or a fraction, you're going to need extra parentheses. Also, what do these big giant parentheses mean? Okay, and on the calculator, we're going to need separate parentheses top and bottom. Does this A1 go on the top, the bottom, or do we need extra parentheses? You could put another set of parentheses, but if you multiply a number, it's automatically to the numerator, right? Because it's like it's over 1. So this is how I will type this. A sub 1 parenthesis, 1 minus, I'm going to put r in an extra parenthesis, divided by 1 minus r. Okay? If r is a positive whole number, you don't need either of those extra parentheses inside. If it's negative, it's really important. If I was typing this in, that's the minimum number of parentheses. It's okay to do this, but is it okay to do this? Make this plus positive. Because negative 2 to the 6th is already going to be positive, so this is actually going to stay a negative. Okay? And students do that all the time. They think, so it's better to just put all the extra parentheses in. Okay? Now I'm going to back and talk about the sum of an infinite series. When you have an infinite geometric series, if the common ratio has an absolute value less than 1, which means this, your ratio is somewhere between negative 1 and 1, then it is converging. Think about that for a minute. If I keep multiplying by half, what's going to happen? It's going to get really little, and towards the end, they're going to be adding almost nothing. So you can find the geometric sum, the sum of those numbers in that series, which is a sequence with pluses, okay? Because it's getting infinitely small, so you can say the sum is found by this. All right. That's all we're going to do on that page. So that formula is here. And honestly, I can't remember if this is on the quiz. If it's not and you need it, I'll put it on the board or something, okay? Because I wasn't all about memorizing. But it's not tricky. It's the first term divided by 1 minus the ratio. All right, and again, that's for an infinite geometric series that converges. All right, let's try these examples. Is this a sequence or a series? What's the difference? Yeah, sequence has commas, series has pluses. I say it wrong all the time, I know. So, is this one finite or infinite? It's, oh, you okay? It's written as infinite, but they want us to find a finite sum. Does everybody see what I'm talking about? Okay, it's written as an infinite series with ... but they want us to find the sum of the first 12 terms only. You can always find the sum of a particular number of items, okay? Doesn't matter if it's getting huge or not. If it's convergent or divergent. If they tell us to find the sum of 10 of them, we can. All right. Anybody remember the formula? The sum of 12 terms is a sub 1 times, you know what, I'm going to write it out. A sub 1, and remember, you're going to need parentheses going to write it like that. That's how it should be on your notes or on the quiz, but you probably want an extra parentheses there. You don't have to put extra parentheses around the whole thing because it's multiplied to the numerator anyway. All right, 6 parenthesis 1 minus. What's 7.5 divided by 6 so that I can find R? 1.5? We can use 3/2 or 1.5. Now it's not negative, so I really don't need extra parentheses. I'll go with it just in case.
Oh, whoops, wrong fraction. Yeah.
You got what?
1.25.
Oh, okay. Thanks.
Scratch them.
That's all right. Do you want me to use a fraction, guys, or not? Okay. 1.25. Now, this is where students get this wrong. It is n, not n minus 1, so it's 12, but it's on that number only, so don't put the 12 on the outside of the parentheses, okay? And then it's divided by 1 minus 1.25, and you can put extra parentheses there, but they won't do anything anyway. But really, you don't need these parentheses either for this particular one. Just be very careful that that 12 is only on the 1.25. It's not on the whole parenthesis. Anybody else get a long decimal? 325 point some garbage?
Yep.
Okay.
325.75.
2459655. Now, if it said exact, that is exact, I think, because it's not like 12 decimal places, and my calculator goes out further. I think if you do a math enter it. I didn't get it to work. Did anybody get it to work?
Oh, wow.
Did yours?
Yeah.
Okay. I think mine might not have because of the way I typed it in. Let me try one more time. It was 5/4. If I put in 5/4, I don't know if it'll go back to the fraction. I thought it went back last period when I did this question.
It's supposed to.
Math, enter, enter. Now this time I did get 58, 44, oh, that's an 8. 67 over 1797. Is that what anybody else got?
I got that.
Okay. Either one is exact. Honestly, on the quiz,
Go with fraction.
well,
Go with crazy fraction.
there was like a question like this,
Yeah.
and I changed it, so I only wanted the sum of the first 7 terms or something so that it wasn't quite so crazy and that you would definitely get a fraction if you wanted a fraction. Either one is exact, but I didn't want anybody to be confused, like, I can't tell if this is exact because I can't tell if it's 12 places. All right. The common, this says find the sum, and because there's dot, 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 this is what kind of a geometric series? Infinite, and we hope it's convergent because otherwise we can't find its sum. Okay, so 40 and 8. 8 divided by 40 is 0.2. If R is 0.2, is that convergent? So you're taking basically 20% of the number, 20% of the number, 20% of the number. It's getting smaller and smaller and smaller. So it is convergent. So then we need to use the sum formula, which is given right here. The first term is 40, and all we have to do is remember parenthesis down here, 1 minus R. I got 50. Okay. That seems small, but if we added 40, we took a fifth and got 8, 1.6. 1.6 times 0.2 gets down to 0.32 really fast. times 0.2, we get 0.064. This was, the sum of right there is 49.92, I think. And what you're going to add after that is really, really little numbers, right? So that's why it's going to say it's approaching 50. All right, just showing you that it works. So can you find the sum of the first 7 terms here?
For sure.
Because it's a specific number of terms, we can do it. It's the first term times what?
Oh,
What's R, guys?
4.
Is it? It's positive, yeah. I was confused for a minute there too. To the what power? Yeah, it's 7. Be careful. It's just n, not n minus 1. Divided by 1 minus 4. Okay? I have more parentheses than I need. I don't need any of these inside here, actually. It's just good practice if you're worried about getting it right. The most important thing is to put that 7 only on the 4, not on the whole parenthesis. That's what I got, Getty. Yep. Sum of 7 terms is negative 5461. Is anyone not getting that? Because I really hope you're typing some of these.
Yep.
Nobody? Okay. Find the sum of a geometric series if.
These aren't so pretty.
Oh, you know what? I don't remember if maybe I did when I did this question last period. We don't know what term this is. Can we find the sum of that many terms?
Yeah.
Yeah, because ours 1/4. I assume they want us to find a specific sum. This is just a weird question. So what we did was we found the number of terms, and then we found the sum of that many terms. So if the sequence is this, what can I put in? A sub n is 0.03125, bless you, times 8 to the times r, which is, 1/4, right? To the n minus 1. What do we do first?
We divide 0.03125 divided by 8.
Okay. So first, if we divide both sides by 8, I love this question because it's review of first semester. How many of you remember what we do when n is an exponent, when our unknown is in the exponent?
Well, no. Yeah, well.
We have to do the log of both sides. Does it matter which kind? No. As long as you do the same one on both sides. And then what happens when you take the log over here? Remember, that guy becomes, the exponent can be multiplied out in front. So then I'm going to divide both of those by the ln of 1/4. This, when you type it in, gives you 4, yes? So then we add 1 and get 5. Now, what if you freaked out and couldn't remember how to do all that? The first term is 8, and you're multiplying by 1/4, right? So the next one is 8 times 1/4. 8 times 1/4, twice. So this is term 1, term 2, term 3. When you get to this decimal, that's the term number you're looking for, right? So we could have done it without. It turns out to be that we are looking for the sum of 5 terms. So the sum through the 5th term should be the first term times 1 minus r to the 5th all over 1 minus r. which is 8 times what? I'm going to use the fraction this time. Parentheses are a little more important this time. This pair up here anyway. You use 0.25, you don't need them, but I got 10 point something. Yep. No? Yes? Anybody?
Yes.
Okay. Give me 1 second.
For the 10 point. Yep. Okay, got that.
Mine did change it back to a fraction if anybody did that. Let me look really quick. Yeah, this should be a 1.1. No problem. Anybody else? Okay, I hope you're practicing because this is an easy one to type in correctly. All right, we could do this a whole bunch of ways, right? We could go alpha and window and choice 2. And we could type everything in if you have the fancy new calculators. Okay? If you have the really old ones, not really anymore, you could do some sequence and just put the formula in. Whoops. Second stat, arrow to the right twice, 5. Second stat again, arrow to the right once, 5. The formula was 5. I don't know if I can use these keys or not. I can. 1.06 to the n minus 1. I think that'll be okay. N, 1 through 11. Am I remembering correctly, guys? I covered it up. Okay? So it would look like this on your calculators. Oh, is mine going to work?
No.
No, the n minus 1 is supposed to be an exponent. I'm going to go back here. Delete. Oh, now what did I delete? The minus 1 should be up there. Okay. Wow, that even works as a fraction. Yeah. Okay. Everybody all right with that? Do I need to put it back up there? All right, find the sum of the first 16 terms. Guys, this question caused a lot of issues because students didn't remember what that meant. So I want to be sure and review. What kind of a sequence is that when it uses n sub 1? Okay, this is recursive. Can you generate a few terms of this for me? 1 is the first term. Then what does this mean? Negative 2 times the previous term, so I'd get negative 2. Then what, though? Negative 2 times negative 2 would be 4. Negative 2 times that. Negative 2 times that, etc. We want the sum of the first 16 terms. Sum of 16 terms is, how does this go? First term times 1 minus r. What's r? It's just negative 2 to the power of 16 all over 1 minus negative 2. Now, if I wanted to use less parentheses, I could make this plus positive or just a 3 and we'd be good. Can I do the same thing here? Negative 2 to the 16th is going to be positive, right? So then this is going to make it negative, so you can't get rid of that. All right, maybe I'll try this calculator instead. This doesn't cover everything up. 1, which I don't need to actually show, right? 1 minus negative 2 to the 16th. Some of you know you could have just made that a positive 2 and then you wouldn't have had extra parentheses. It's going to come out positive. Divided by, I could just say divided by 3, but I'll go 1 minus negative 2.
Yeah.
Yes, 21,845. All right. These are asking you to find the sum of an infinite geometric series. We can only do that when what? Convergent, yes. Less than 1 is the radius. Can you tell the radius? The ratio. Can you tell what the ratio is on number 10?
3/8.
Yep, they're multiplying by 3/8 over and over. Can you tell what they're multiplying here on 11? And can you tell what they're multiplying by on number 12? Yeah, you got. If you put in a 1, you'd get 3 to the 0, which would be 1. You put in a 2, 2 minus 1 is 1. 3 to the 1 is 3. Put in a 3, 3 minus 1 is 2. 3 squared is 9. So what is the ratio? Yep, the ratio is 3. Which ones can we do? 10 and 11. We can. This one is not convergent. So we cannot find the sequence. I'm sorry, the sum. All right, back here, what's the formula to find the sum of either of these? Okay, this one's going to be infinite, but it's the first term over 1 minus the ratio. What's the first term here? Yeah, because if you put in a 1, this will be 0. 3/8 to the 0 is 1, so we just get a 13 over 1 minus 3/8. And you actually wouldn't have to have those parentheses. What is 1 minus 3/8, guys? Huh? 1 is...
Oh, wait, what? Oh,
1 is 8/8, yes?
Yeah.
So it's 5/8. Thanks, Max. 13.
I was giving you the total sum, so.
I got 20.8. Anybody?
Yeah. Trying to get to that.
Or 104 over 5. All right, let's try this one. What was the first term?
So,
Yeah, that should just be 20. 10 divided by 1/2 is 20. Does that make sense, guys? What do these first 3 terms add up to? Yeah, and 18.75. But we're going to keep adding tinier and tinier amounts, right? So 20 seems okay. All right, couple applications real quick. Each year, the value of a car depreciates by 18%. Okay, really have students struggling with this. If you have the whole value and you are depreciating, which means subtracting 18%, what percent of the value is retained or remains? 82%. So what decimal are we going to multiply by? 0.82 over and over. Okay? So we bought the car for $22,000 and it gets multiplied by 0.82 every year it goes down in value. So if this started in 2009 and we want to know its value in 2615, what are we going to use for an exponent power? 6, yes. Okay. This
Kind of, not the right one.
exponential growth and decay is exactly right. We did this before this exact question, probably. Okay. 22,000 times 0.82 to the 6th. Pathetically, before your car has 100,000 miles on it, it's all the way down to this much. I'm just going to round to the nearest dollar. It's like worth $6,700 from 22,000. Okay. It depends on a lot of things. The mileage, obviously, but it also depends on the make of the car. Some models of cars retain their value a lot longer because they're, some are made to go 200,000 miles. And it could go down that much, yeah, it could. All right, this is a trick question to me because I didn't read it carefully the first time. How many years did it take for it to do this? So they're saying every decade it grew this much.
Oh, wow.
Okay? It's not every year, every decade.
So decimal 1.2.
Yes, so 100% of the people stayed there and it grew another 23.5%. Which would be 1.235 after we added and moved the decimal over. The original population was already big. Did I get all those commas and the numbers right? Okay. What will the population be in 2030? So from 2000 to 2030, how many times did it grow?
3.
Only 3 because it's decades, yes. People, oh, I started to write dollars. I got excited about that many dollars, but all right. Yeah. All right. One more question, quick. Did you not get that, Getty? Oh. It's a big number. All right. An employee, this time they give us his 10th year salary. What were they multiplying his salary by, guys, to get an increase of 4.5%? Except he gets all of it plus more, right? So it's 1.045. So he had a starting salary. They multiplied it by that. How many times for his 10th year of work? How many raises did he get if this is his 10th year of work? 9 is right. Good job. Okay, so real quick, divide 50081.41 divided by 1.045 to the 9th. He made about $33,700 his first year. And then what do they want us to do? How much did he earn for those 10 years? So we want the sum of 10 terms where the first term is, and then it's 1 minus, the rate is 1.045. Remember, in the sum formula, it is an n, not an n minus 1. I don't know, I screwed something up here. Oh, no, I have, no. There we go. 414,000. I swear that's not what I got last time, but it's right. I think I did it wrong. It's a good thing I re-recorded. Okay, so the assignment is here.
Probably do this in a